All right, welcome everybody to today's Energy Code presentation. We will be talking about existing commercial buildings and energy code compliance. Joining me today is my colleague Ryan Siegel. My name is Sean Maurer. I'm the technical director here at the Smart Energy Design Assistance Center. What we'll be learning today, first we're going to go over the scope and applicability of the energy code as it applies to existing commercial buildings today. We did cover existing residential buildings earlier in our program year, so today's focus is on commercial. We'll be explaining the differences in code requirements for additions versus alterations, repairs, and historic commercial buildings. We'll apply some real-world examples from assistance that we've provided to clients in the past to help understand how to apply the provisions in Chapter 5 to existing commercial building projects. Then we'll identify how improving existing building stock is a key to improving sustainability and resiliency as we go through some of those examples. So a little bit about ourselves. We are the Smart Energy Design Assistance Center. Our mission here as an applied research program at the University of Illinois is to reduce the energy footprint of Illinois and beyond. Again, we are an applied research program. We help facilities become more energy efficient through education, research, and advocating for a greener future. As part of the education, we have partnered with the Illinois Office of Energy. We thank them for the support of this program to help educate people on the codes, keep architects, code officials up to date on the most current standards, where the codes are going, and how to use the codes to improve building performance and resiliency. We are a preferred education provider with the International Code Council, and we do have continuing education credits available through AIA. When you registered for this webinar, you should have been able to enter a member number so that we can submit those credits for you on your behalf and make this process as simple as possible. If you do need additional learning credits, we do provide a certificate of attendance so you can self-report for any other programs. And we'll also be posting this presentation and the slides to our website as a resource. If someone wasn't able to attend, wants to review this information in the future, they'll be able to access that at our website, smartenergy.illinois.edu/energy-code. As part of our program, we do provide technical assistance. If you have an energy code question, need some clarification, you can send us an email at energycode@illinois.edu, or you can call us at a 1-800 number listed there on the screen. We do prefer, if you have a complex question, that you do send us an email that lets us review the question in depth, get you the best answer possible, and also you then have a written record of that response that you can supply to everyone involved in the project so that you're all on the same page. But if you do have a quick question, just a point of clarity, something like that, that 1-800 number is available as well. As far as our resources that are available at our website, we host all of our past workshops and webinars on our webpage. We also have some self-paced on-demand training modules that are there for you to use. You can take those modules at your own pace, and once you complete them, you do get continuing education credits for those as well. So this is bringing us to the end of this program year's webinar schedule. So today we're talking about existing commercial buildings. You can see all our past webinars again posted on our webpage. They are archived there for your review, but listed here is everything that we've covered this program cycle. We do also have an in-person workshop scheduled in Rockford, Illinois for June 11th. We'll be covering code basics, how to simplify the code so that you can use some of the language in the code to make your projects as simple to comply as possible. So we'll be going over that to help you better understand and navigate through the codes as part of that in-person workshop. The Illinois Energy Conservation Code was updated on January 1st, 2024 to the 2021 IECC with some Illinois amendments. So if your permit application was before January 1st, 2024, you'll still be complying with the 2018 IECC. But for permit applications on or after January 1st of 2024, compliance would be through the 2021 IECC with those Illinois amendments. You can access the IECC from our webpage along with Illinois' amendments or the Chicago Energy Conservation Code, Energy Transformation Code. We also have links posted here so that you can access those from this webinar if you're pulling this in the future. As with the IECC, the City of Chicago has worked with ICC to get their code published and sourced at ICC's website. Illinois is working on an adaptation as well, and that may be published to the ICC. So that, again, that incorporates all the amendments. You're not having to reference separate booklets. They're all in one place. So just a brief overview here of the arrangement of the 2021 IECC. Chapters 1 and 2 go through administration and definitions that are important for code compliance and understanding. Chapter 3 goes over climate zones. Chapter 4 is new construction energy efficiency requirements. Chapter 5, which we're going to be focusing on today, are the existing building requirements. And mainly this chapter goes over some specific provisions for existing buildings and then references back to the relevant sections of Chapter 4 as required. And then Chapter 6 is the reference standards in the code. So things like NFRC ratings come from an NFRC standard. The most current version or the version used for this code cycle will be listed there so that you can access the correct information by looking at those reference standards. So before we move on into our general section, we'll host a little post here, get an idea of how much you're working with existing buildings. So for our first question, what section of the commercial code have you struggled with the most? Is it understanding the different compliance methods, the building envelope, mechanical systems, domestic hot water, power and lighting systems, or other? It looks like this may be an older poll set. We'd intended to ask here about your involvement with the existing codes in commercial buildings, but we'll let you respond to this. Okay, we'll go ahead and end that poll, share the results. This does help us understand a little bit, especially if you're replying to this in terms of existing buildings where you might struggle a little bit. So looks like fairly even spread for buildings, understanding the different compliance methods, building envelope, mechanical systems, power and lightings, not as many there. And then on the residential side, again, pretty even spread across all the options there. At this point, I'll turn it over to my colleague Ryan to talk a little bit about the general provisions in Chapter 5.
Well, thank you, Sean. Just a reminder for those of you who might have questions as we're going through this material, please go ahead and use the question and answer function. Should be towards the bottom of your screen. I can select that and go ahead and ask your question. We will try to answer those either during the presentation or at the end. If you do ask questions in the chat, we might miss those. So again, please do go ahead and use the question and answer function if you are able to. So looking a little bit at the general provisions. So first, understanding how this chapter is laid out. So how the code works is we're going to begin in Chapter 5, since we're dealing with existing buildings, and then, as Sean mentioned, it will refer back to Chapter 4, the applicable requirements where it is required for existing buildings. So Chapter 5 begins with the scope, and then second is dealing with the compliance, also dealing with maintenance, new and replacement materials, and then historic buildings. So these are the general requirements regardless of what this project is for an existing building. So for the scope, it covers a few different options here or features. So this includes, for existing buildings, we might be dealing with additions. That's perhaps some of the more common work that occurs, or at least the more straightforward work with the energy code is when you're doing additions. When you're dealing with alterations, so this is where you may be doing any number of changes to a building. This could include things such as you're adding insulation to a building, replacing an HVAC unit or replacing windows. All of those would be examples of alterations to the building. Repairs, this is where we have a particular set of damage that we are trying to repair and remedy from an event that occurred. And then finally is a change in occupancy. So as noting here, each of these have their own specific requirements in their own section within Chapter 5. Which we will cover in much greater detail as we go forward. So as far as how compliance works with the code, we mentioned the 4 types of work: additions, alterations, repairs, and change of use or occupancy. Additions, here it's noting strict compliance, or this is direct compliance. So everything that is in the addition needs to comply with the code, similar to as it is for new construction. It's perhaps some of the easiest to deal with, other than the transition, where you have the existing touching the addition. Those transitions can get a little tricky for you. Alterations, we're deeming here as moderate compliance. What that kind of deals with is whatever your alteration is covering, that needs to be brought to the current standard with, there are a few provisions and allowances for that. So we're calling out moderate compliance. And then repairs oftentimes do not have any direct compliance other than to return it back to the way it was before the damage occurred. So we're calling that here limited compliance. The big one here is if you trigger a change of use or an occupancy, that is strict compliance like it is for an addition. However, that also includes the existing building too. So that is definitely a big one, and one of the few areas in the code where it requires an existing part of the existing building to comply with the current code. Generally, again, the code deals with whatever you're touching, that's what we care about. But if you trigger change of use or occupancy, that now we're dealing with the entire building and bringing the whole thing into compliance. So we do also note here that relocation, there is a provision in there for if a building is relocated. Typically, this is going to be likely of a historic nature where you have a relocation. And so it's a little less clear, but in this example, what the relocation would be is likely the new foundation that you're putting it on, that would need to comply, but your existing facility that's been relocated generally would not have to be touched with that. So as far as maintenance, the code talks about building maintenance. Again, the importance here is getting that we're in a safe and sanitary condition over the lifespan of this building, and that the building components need to be maintained over time. So you can't reduce performance through maintenance. So if you make a wall repair, for example, you can't remove the insulation that was in the wall and then not put it back. Obviously, you can put new insulation back in its place from the insulation you removed, but you cannot leave it just uninsulated. So again, the goal here is we want to maintain the level of performance of a building, not diminish it over time. So many times maintenance aspects are going to be not covered under building permits. Local jurisdictions generally don't require building permits for routine maintenance. So things, painting and patching of walls, things like that. Component replacements, a blower motor fails in your heating unit and you're replacing the blower motor. Generally, those don't require permits for that. So you'll notice that maintenance and repairs are oftentimes very closely aligned with each other. So recognizing when do I have a repair or when do I have an alteration, the code does not call out a specific percentage threshold. Your local jurisdiction may have a threshold where they say beyond this, that's no longer a repair, that's really an alteration. But the code is really looking at repairs saying, we're doing reconstruction or renewal for the purposes of maintenance or to correct damage. So as we see on the right-hand side of the screen there, that drywall patch, someone may have damaged the wall, and so we are making a repair to repair that damage or dent that had been made into the wall. Now there are several items that are called out in the repair item that the code is calling, stating that these are repairs, regardless of if they require a building permit or not. Generally, work that is not that doesn't require any building permits is typically considered maintenance or repair for the purposes of code. Alterations, again, looking at, are we changing the characteristics of the building? Are we going to be changing or adding insulation? Are we changing the type, size, efficiency of the HVAC unit? So that is something where just replacing an HVAC unit, people will say, well, it was like for like. However, you probably have improved the efficiency or you have made other improvements given that new unit. So that would typically, that may be classified as an alteration. Again, replacing the blower unit, that's probably going to be a repair, not an alteration. Code calls out that new and replacement materials should be used as far as if it's new construction. So you are allowed to reuse and repair with the existing type of materials as long as they are not going to provide a hazard to life or health. So some of these would be things like, as shown here, lead paint or asbestos pipe insulation. Because these are hazardous materials, they should not be used and are not allowed by the Energy Code to be used for repairs. So if I was to remove this asbestos pipe insulation, I need to go back with new pipe insulation, but that could not be done using asbestos pipe insulation. Because again, these are hazardous materials that we do not want to continue their use for that. Had some questions on historic buildings. Something to recognize is there are two different definitions for historic buildings. This one shown here on the screen is the one directly out of the International Energy Conservation Code. And if it falls within this definition, then the provisions in the code for historic buildings would apply. And there is a slightly different definition for the state of Illinois. So we will note that. So first we'll go over the IECC's definition and what that applies to. The Illinois definition is a little bit more specific. However, it provides an exemption from the Energy Code completely. So the IECC exemption for historic buildings is much more limited. So for the IECC, a historic building is listed or certified as eligible for listing by the state historic preservation officer or the keeper of National Register of Historic Places. So again, this is listed or certified as eligible. Not just eligible, but you have to get the certification letter as eligible for it. Also could be designated as historic or certified as a contributing resource within National Register listed or state designated historic district. So with that, recognizing that the Illinois definition requires it to be very much more specific. That being, it has to be listed on the National Register or the Illinois Register. So it has to be listed, cannot just be eligible. Or it has to be designated by the authorized personnel as historically significant. So typically that's going to be your Historic Preservation Commission or that would do that designation. So, and for Illinois, if it is a listed building or designated by the authorized personnel, you don't have to deal with code compliance. If you do have to submit for it as part of your building permit, if you are working on a historic building, you would list that as this is an exempt project from the energy code. So again, if it's eligible for listing, or if it's contributing as part of a historic district, that is still going to require some code compliance for the energy code. And what that code compliance looks like is if they are designated as significant, they are exempt from the specific provisions if it modifies the form, fabric, or function of the building or building component that is related to their historic designation. So, for example, in the city of Chicago, in the cultural center, there's a beautiful Tiffany's dome that is designated as a historic artifact, and so the code would not require that dome to be upgraded to the current standard, but that would not preclude, say, adding insulation to the wall or other similar type of work, pipe insulation, things like that, that would not be damaging to that historic fabric or that historic designation of that. So, and that's where if you're eligible for listing, again, that's where we're going to be very specific about what is the particular item that is potentially damaging. And so calling that out as part of your building permit, that if I was to comply with this provision, here is the damage that would be incurred by that. So being very specific about that for historic buildings. If we're adding additions to historic buildings, the additions are not exempt. They have to comply with code. The historic portion may be exempt and preserved in its existing condition, but the addition would have to be built to the new codes. So with that, I think we have a poll to put on. It's calling out which of the following projects would be exempt from updating to the current efficiency codes of the energy code per the existing building provisions. Addition of a penthouse floor to a historic district building, modifying a curtain wall assembly to have more opaque area, replacing a domestic water boiler in a multifamily tower, or replacing an air conditioner compressor in an RTU. All right, and several of these are specific to lighting and other things that we might get to later.
Did have one come into the chat. We're asking about replacing a furnace that is no longer functioning. Is that an alteration or a repair? typically that is an alteration because the new furnace is going to have uh, newer efficiency. If you're replacing a component of that furnace, such as the blower, that would be a repair. Um, okay, looks like our poll responses are in.
Looks like many people picked up on this. So yes, the exempt item is replacing the air conditioner compressor in a rooftop unit. Again, since this is a component, this is likely to be a repair and therefore exempt from updating to the current requirements. With that, I'm going to turn over to Sean to talk a little bit more about additions.
All right, well, thank you, Ryan. So for additions, as we noted earlier, this is a section of the code that has somewhat strict requirements as the addition itself has to comply as if new construction. Where it does get a little bit of leeway is where it connects to the existing building. So in addition, extending the conditioned floor area or space of a building. This could be an internal conversion, so an entirely enclosed, say, unconditioned warehouse, if that's turned into a conditioned office space or something like that. That is an addition, even though it's enclosed in a building and doesn't expand the overall footprint of the building. It is expanding the conditioned footprint of the building. Or it could be a typical addition where you're adding a wing onto a building or a floor on top of a building. Those all qualify as additions. Um, additions to an existing building, um, um, building system or portion thereof shall conform to the code as it relates to new construction without requiring unaltered portions of the building to comply. So again, where you're tying in an addition to an existing exterior wall, that exterior wall, where it connects, you have to modify the wall. So that modified portion would need to comply with the code. But the unaltered portions where you're not doing work on that wall assembly would not have to be updated. You wouldn't have to update the roof of the existing building. Only the addition has to fully comply with the code. The connections to the existing building would comply with the alterations portion of the code. An important part about additions is they can't create an unsafe condition. So if you're adding a floor to a building, it can't structurally overload the building. If you're adding in conditioned space, it can't overload the existing HVAC systems. It would need to have its own standalone HVAC system. So that's an important part about performing an addition to a building. Additions can comply with the code alone, so you can model the standalone system or do a prescriptive checklist compliance for the addition alone, or you can include the existing building's performance. If you're doing extensive renovation in the rest of the building as well, that may be an alternative that makes sense. Additions converting unconditioned space to conditioned space need to comply with C502.2. Other additions will typically comply with C502.3, and this is where we're talking about a change of use or occupancy versus a standard addition. We'll get into the differences between those here. So for C502.2 has some specific requirements. Any non-conditioned space that's altered to become conditioned space shall be required to be brought into full compliance with the code. An addition or change of space conditioning requires that you start back in Chapter 4 and work through as if it's a new construction project. So the envelope has to comply, then the HVAC systems, service hot water systems, lighting. You would work through Chapter 4 as if it were a new construction project. Unaltered portions of the building connecting to that addition do not need to be updated. Again, they would comply under alterations if you do need to make changes, but depending on the type of alteration, may not need full compliance with the code. So they would comply with the alterations portion of the code. We did recently have a question about a change in space conditioning within a portion of an existing building. The exterior envelope portions of the project space must fully comply with Chapter 4. So where this particular project was expanding a conditioned office space into a warehouse, where that space touched the exterior walls, those would have to be updated to full code compliance. The roof above needs to be updated to full code compliance in terms of envelope insulation. HVAC and lighting, part of that upgrade would have to be full code, but the rest of that warehouse area could be maintained as is, since the rest of the building was not being modified. So there is that slight allowance there, where just the part of the building that is involved in the addition, if you're working entirely within an enclosed shell of the building, would need to comply with Chapter 4's requirements. So for a change in use or occupancy, there are certain exceptions to full code compliance, where the code does acknowledge that you're working within an existing building. There are some limitations and difficulties that arise from that. So it gives you a little bit of leeway in compliance. The first exception here is if you're looking at the envelope of the building, you can comply through the envelope using the UA trade-off methodology in C402.1.5. But it allows you an extra 10% beyond the code. So you can be 10% worse performing, accounting for there are connections to the existing envelope. There are differences in thickness of walls that might change because of added insulation. So they're allowing a little bit of leeway here for that UA trade-off to account for those tie-ins to the existing envelope around the area that's being converted as part of the addition. Note that this only applies to changes in space conditioning, not to full additions. So for full additions, we'll cover that separately here. The second exception for full compliance is that changes in space conditioning using the performance path can comply if the total energy cost is no more than, again, they give you that 10% leeway beyond what the reference model design says the energy consumption should be. So again, this applies if you're looking at a change in space conditioning, accounting for those difficulties in modifying that space within an existing structure, where they give you that 10% leeway. If you're looking at an addition separately, instead of a change in space conditioning, the addition would not have that 10% leeway. So looking at C502 for additions, as far as C502.3, new building envelope assemblies that are part of the addition shall comply with the relevant sections of Chapter 4. So the thermal envelope requirements, including any exceptions for low energy building space. C402.2 as far as prescriptive requirements for assemblies for walls, foundations, floors, fenestration requirements in C402.4. There are some specific notes about fenestration in C502.3 that we'll get into that provide a little bit of leeway for an existing building. And then your air sealing requirements for the envelope as well. So again, as part of the addition, you're going to comply with these as if it were a new construction project. So you're just going to start at the start of Chapter 4 and work your way through. For fenestration, the exception for additions to a building in C502.3 is that I'm going to kind of lump these together for vertical fenestration and skylights just by talking about the vertical fenestration component. Again, it's very similar for skylights, as you can see in the table here, but if the addition to the building results in a total building window to wall ratio that is less than 30%, you can comply with any of the compliance methods for the fenestration. You can use the UA trade-off, the max U factor and solar heat gain coefficient section, or do a performance model of the building. If the addition results in a whole building fenestration ratio between 30 and 40%, where for a new construction building, this would trigger the requirements for daylighting, where you have to, where that fenestration has gone beyond that 30% minimum or maximum window to wall ratio. There is that allowance for up to 40%, if you have daylighting in the addition and some fenestration performance requirements as well, as listed in C402.1.1. If the addition results in a window to wall ratio that is over that 40% maximum, then you have to comply using the UA trade-off method or a performance model that shows that that building is using less energy than a reference design. And again, it's very similar for skylights, except it's that skylight ratio instead of the vertical fenestration window to wall ratio. One thing we do note, the Chapter 4 skylight exemptions do apply to an addition to a building. So if you can get your general lighting power density less than a half watt per square foot, which is very feasible with modern LEDs for building design, then skylights are not required in the addition. There are also some exceptions in Chapter 4 for requiring skylights. And many times these are applicable to an existing building where, especially if it's a multi-level building, part of it's going to shade where a skylight might be required. So if structures or natural objects block daylighting for 50% of the roof over the enclosed area more than 1,500 daytime hours between 8 o'clock and 4 o'clock p.m., likely then skylights are not required. And this is, again, likely if you've got a tall building, you're adding a shorter addition onto that building where the taller part of the structure could shade that addition's roof, in which case these exemptions might apply. Again, for Chapter 4, where there's a daylight zone under the roof monitors, if that's greater than 50% of the enclosed area of the addition, this is somewhat unlikely, maybe situational. Then again, skylights could be exempted because you're getting your daylighting through a roof monitor through a large area, and you're getting your energy trade-off from the daylight controls. Where total area minus the side-lit area is less than 2,500 square feet. So again, you're making a small daylit area, and that daylit area is controlled with daylighting controls as per C405.2.3. Then this is very, very likely to achieve in a smaller footprint addition. Again, skylights would not be required as you're getting your energy savings through the daylighting controls already. And if your addition is a designated storm shelter, then you also don't need skylights. For envelope air sealing compliance, additions to a building do need to be tested for the envelope. There is no exemption for existing buildings. So the air sealing testing must be done. Again, for climate zones 4A and 5A, there are no exceptions to that testing requirement for new construction. So there are also no exemptions for existing buildings. So the addition must meet that 0.3 CFM per square foot target for new envelope area. You can isolate an addition from an existing building to pressure test only the new envelope. You can do this with a guarded blower door test where you pressurize the existing building to the same as the addition so that you're not drawing in leakage from the existing building. And that way you're only testing the portion of the project that is the addition, and you're not getting leakage from the existing structure impacting the test. As far as additions, mechanical systems, lighting, service, hot water, those all would comply as they would if you were starting from Chapter 4. There are no allowances for new systems and additions as far as exemptions from full code compliance. Lighting requirements can apply to the addition alone, or they can apply to the addition and the existing building combined. So in terms of lighting power densities, lighting controls requirements, the daylighting requirements, you can look at just the addition, or you can look at the addition plus the existing building for compliance with those provisions. But as far as HVAC and service hot water, again, as we noted earlier, generally if you're making an addition to the building, if you had a well-designed HVAC system or service hot water system, they should have been sized for the existing building's loads. The addition would push beyond those loads. So they should either have their own systems or the existing systems updated to handle the additional loads for the addition. All right, so that brings us up to our next set of poll question. So just a little bit of a test here. A contractor is working on a 10,000 square foot warehouse conversion to a heated and cooled office using a 25-ton heat pump system. Which of the following would apply to the project? Is the insulation exempt, as the space is a low energy building? Is air leakage testing exempt, as it's an existing building? Do new ducts for the HVAC system not need to be insulated? Or can a performance model of the warehouse, is that allowed to have 10% worse compliance with the code than a reference design warehouse with this addition done?
See, we did have a question come in regarding adding insulation to a wall that is common to an existing building, and the existing common wall changing more than 60% of its original design. Will that common wall be required to meet the new code? For that, the important thing is understanding where is it part of the building envelope. So it may be such that when you put an addition on, a portion of the wall that used to be part of the building envelope, due to the addition no longer is part of the building envelope, is that that building envelope now comes across the addition as well. So if it is not part of the building thermal envelope, then it would not require insulation because that is required of the building thermal envelope. At least as far as the energy code goes. There may be benefits to leaving that insulation in for sound or other reasons, but the energy code would not require, does not require walls that are not part of the building thermal envelope to be insulated.
Yeah, it looks like we got all our responses in, so we'll share those poll results. It looks like most people got this correct. For this existing warehouse conversion, it's a changing condition space within an existing building. A performance model can perform 10% worse than the reference design. You do have that leeway, but all the others do not apply to this project. You do have to have full code compliance for insulation. It doesn't qualify as a low energy building, as you're well over that 1 watt per square foot. Air leakage testing, as we noted earlier, is required for existing building construction, and any new ductwork or anything would have to comply with insulation and air sealing testing requirements as new construction in commercial buildings. Okay, at this point, I'll turn it back over to Ryan to talk about alterations.
Thank you. Yeah, this is where all the fun begins. Alterations. So part of this is recognizing what an alteration is. So this could be retrofit or renovation to an existing structure other than a repair or an addition is an alteration. So the code tries to be very good about trying to avoid overlaps. And so it's calling out that if it's not a repair or an addition, then you're in an alteration for that. So also calls out that alterations shall be such that only the altered portions need to be brought into compliance with the code, provided the existing unaltered structures don't diminish their level of performance as well. So you can't make it any worse than where it was before you started. So envelope, again, leads back to section C5. 503, which is going to point you back to chapter 4. And so alterations, again, cannot be less conforming than it was before it started. And alterations do not require the unaltered portions to be brought up to the current standard. Now, there may be reasons that a project may wish to go ahead and include portions of the building that were not originally intended to be part of the alteration, just to make things a little bit simpler and easier to construct. And again, alterations, we do not want to create any hazardous conditions or overload existing systems, typically structural in nature. So there are a few exceptions that the code calls out for this and says does not require full compliance or may not require compliance at all. So some of these storm windows, it's less common these days, but if you install storm windows over your existing, we don't need to demonstrate compliance. Similarly with window films that are applied. Construction where the existing roof or wall floor cavity is not exposed. And this is also, obviously, this is common for masonry walls that may just have some furring strips. That's not a cavity that is being exposed. A roof recover, understanding what the definition of a recover is, that is installing a new roof membrane over the top of an existing membrane that has been prepared for that. So there's a few exceptions here where the code is calling out these are not really alterations that require code compliance for it. So as far as dealing with new envelope assemblies, then we do need to have insulation installed and they do need to comply. Now there is a provision that I didn't see noted here, and that is if you do expose cavities as part of an alteration, as long as you fill those cavities with insulation, that is deemed to be code compliant for an alteration. So just because you open a cavity and you say, well, I can't put R30 or R20 cavity insulation in this 2x4 wall, it's okay. The code says just as long as you fill that cavity, that is deemed to be code compliant for existing buildings or existing alterations that you're doing. So also calls out as far as the envelope fenestration area, there are the limitations in the code as far as that 30 to 40%, depending on if you have the additional daylight harvesting controls or not. The code does allow you to maintain excess fenestration areas. Now the new fenestration does need to meet the U factor requirements, but you do not have to downsize the fenestration in order to get it under that 30% limit. So there is a provision there. So in this picture here, where we have some fairly large windows, code does not require those to be downsized to meet the 30%, but you cannot increase the window area for that. So, when doing a roof replacement needs to comply where the roof is part of the building thermal envelope. And the insulation is entirely above roof deck. This is typically found for low slope roofs. This is calling out that you need to bring the insulation value during a roof replacement, not a roof recover, a roof replacement. You need to bring it up to the current standard. There is an Illinois amendment that has a provision in there to make that a little bit more feasible, such that if you are limited as far as how much insulation you can put in, the amendment indicates or calls out in not so many words that you have to do the best within your existing constraints. You have to identify, here is the reason I cannot put in more insulation, and here's the maximum that I am able to for that. So again, there's an Illinois amendment on that. Skylights, again, fairly similar to the fenestration. You cannot go you cannot increase the size beyond the limits, but if your envelope already is above the limit, you may maintain that for the alteration that you are doing. HVAC and service water systems, again, whatever you're replacing, that needs to meet the requirements of new construction. That includes both HVAC as well as that service hot water systems. Need to have that full compliance for whatever your replacement equipment is. So, lighting does have a provision in there noting, yes, you do need to comply for new lighting systems. There is an exception for alterations that are replacing less than 10% of the luminaires in a space, not in a building, in a space. So that's trying to note that, hey, if you need to replace a fixture for some reason, yeah, we're not going to throw that into the full compliance requirements. So there is that that's a fairly low threshold to hit for it. As far as repairs, we're moving into repairs. So now that we've touched on additions and alterations, now recognizing what is a repair. Mentioned earlier, as far as the purpose is to maintain or to correct damage. Code again also calls out the following items are defined as a repair. So even if these were to require a building permit for your jurisdiction, the code is calling out that this is classified as a repair. So a glass only replacement in an existing sash and frame, that would be a repair. If you replace the window, including that sash and frame, that's going to be an alteration. Similarly, roof repairs, and noting if you're doing a roof, an air barrier is not necessarily required if you're not going to be touching the rest of the envelope as part of that. And replacing exterior doors doesn't trigger a replacement to install a vestibule, but if a vestibule is required, you can't remove an existing one for that. And for lighting, I had mentioned earlier, if you're doing more than 10% of the fixtures or luminaires in a space, but here it's calling out if all you're doing is changing out a lamp, ballast, or both. So if you're doing just a LED conversion, where you're just replacing the ballast and lamp, that is not going to cause full compliance. We don't see too many lighting projects that where full compliance is difficult to achieve either, even if it does. Change of use or occupancy. This is the big boy. If you trigger this one, that is any space that's undergoing a change in occupancy that would increase the demand for electricity or fossil fuels needs to fully comply with the code. Typically, jurisdictions will use a method to say, do I need to upgrade either the gas service or electric service or larger HVAC equipment? So if I have more demand for cooling, more demand for electric, or more demand for natural gas, that is indicating this is an increase in demand for electricity or fossil fuels, and therefore likely to trigger this provision. So there is some exceptions. So if you're close, very similar to our additions that Sean talked about earlier, if you're within 10%, then you're deemed to be close enough. But if you're beyond that 10%, which 10% is not a very, very high bar, particularly as we continue to move to newer and newer code versions. So unless it's a very new construction, that 10% is going to be probably what's going to pick you up. But again, if you trigger this change in use, so for example, we're showing here, this used to be just a warehouse building, and now we've turned it into some beautiful residential loft apartments. That is going to increase the use, and therefore the entire building needs to be brought up to the current standard. So the thermal envelope needs to be to the current standard, lighting, HVAC, domestic hot water, etc. is that. So that is a big provision if you end up tripping over that one. Do have a poll that I don't think we have a picture of. So we'll skip over that. So just a reminder, we do have an in-person training coming up here on June 11th. That's going to be in the morning, 9 to noon, in Rockford, Illinois. So I'd do hope that some of you will join us there so we can see you in person, and that's on Code Basics, Simplifying Code Compliance, and Submitted Questions Answered. So again, that's June 11th from 9 to noon in Rockford in person. Do have several questions that have come in. One of these is, does a lighting retrofit kit fall under a lighting repair? That may depend on if it's just a lamp and ballast change, or if it's something more than that. Again, typically for something like that where you're doing a lighting retrofit, we don't see too often that a building permit is required for those. And a building permit being required is what triggers the requirement for energy code compliance in the state of Illinois. We have a question regarding adding windows to a building envelope creates non-compliance with an energy code comp check. That sounds like it's going to be fairly project specific, so we would encourage you to reach out to us with that question. You might be able to provide some supporting documentation with that to illustrate that point. Again, our helpline is energycode@illinois.edu.
And it's possible that's one of those ones where existing buildings have an allowance where if there's existing window area beyond that 40% max window to wall ratio, it doesn't require you to reduce it. But if you're adding windows and you trip over that 40%, that would be non-compliance, unless you're doing a performance path or UA trade-off.
And that is perhaps one of the areas that we often see people get tripped up when doing a com check or for an addition, is they try to put the entire building into the com check and not just the addition that they are working on.
Mm-hmm.
So that's a common place we see people getting tripped up.
A question here about a single office enclosed with partitions, floor to ceiling. Would that require a motion detector with a dimmer timer, or is a standard light switch with designated turn off times or the manual override acceptable? So if this is a conversion of that office space, you're going back to the C405 requirements for lighting controls. And so for a single occupancy office, that would require an occupancy sensor in that space.
Let's see here. Doing a tenant space in a retail strip, occupancy change from mercantile to assembly, restaurant specifically, or an educational daycare use, but you're not touching the shell of the building. Does that trigger full compliance? Again, that is going to depend on if that change is going to increase the demand for electricity or fossil fuel. Then it would. If that change in use does not increase that demand, then full compliance would not be required, only whatever you are altering for that. So it's going to be specific to your project. Roof membrane being replaced. Does the insulation below the membrane have to be replaced? And does the roof assembly need to comply with the code? So if you are replacing the membrane, so this is not a roof recover. So this is you are removing the membrane. The insulation, if it is in good condition, we see no reason why it cannot be reused as is. Any damaged insulation would need to be removed and replaced. But the roof assembly does need to comply with the code. So you do need to add your insulation as much as is required, or as much will fit per the Illinois amendment for that.
Question about windows in a historic building, and this can be tricky. As long as the replacement windows can be made to look the same and operate the same as the historic windows, they should comply with the energy code U factor and solar heat gain coefficient requirements. We have seen in certain instances with particularly old windows done with float glass where they've got that wavy contour to them. Um, there may be an exception there where newer windows won't have that wavy feature to them, so you don't get the distorted view looking out through the glass. Um, Rebuilding of windows is another potential method for historic windows where they're revamped and reusing components of the window. That can be tricky, and it's can be a case by case analysis there.
Yep. That's definitely one to seek out your historic preservation on that.
Yeah.
If you are, they will be able to tell you. Sometimes it may be only certain facades that they look at and say, no, you cannot replace all the windows. You cannot touch the ones on this facade, but the rest of them you are allowed to replace without damaging the fabric. Some of them they may say you know all of them are historic. So that's where that damaging of historic fabric judgment call comes into play. And so reach out to your local historic authority on that.
So they have an addition to an existing building with wood truss roof structure. Any recommendations for how to isolate the existing attic from the new attic to perform air leakage testing? So the attic itself, if I'm understanding your description here, the attic is outside the thermal envelope. Your ceiling level and the insulation on top of that ceiling is your thermal air barrier. So the connection between the attics should not impact your air leakage test. You would be isolating the existing building from the addition within the thermal envelope. So your existing building, you would pressurize with a blower door to the same pressure as the addition, at 75 pascals. Um, and then you would conduct the blower door test on the addition. And so any air leakage through that ceiling assembly, through your thermal envelope, would be part of that test. So you wouldn't have to isolate the two attic spaces. That should not impact the air leakage number.
Uh, just a reminder note here about roof recover. So this is where you are going to install a new membrane over an existing membrane on a properly prepared substrate. That is not requiring full insulation at that point. When it comes time to remove roof membranes, that's where the new insulation will be required.
Does relocating an existing light fixture count towards the 10% replacement?
The
There isn't really language around moving fixtures, but that technically would fall under an alteration. Um, Again, if it's less than that 10% of the total lighting in that space, then
Yep.
full compliance would not be covered.
The code says replace less than 10%. So
Yeah.
if you just move one fixture from one spot to another, presumably from to rearrange a little bit of the light on the floor and to deliver appropriate lighting to an area, you know, that's again, you're probably not going to be dealing with the building permit to move to move one fixture. You may or may not need a building permit for that, and so probably not likely to be there. But if you move, you know, 72 fixtures from one space to another, that's an alteration.
Is there a percentage limit for flat roof replacement repair before insulation is required? Many times a partial roof is replaced. So the energy code here is vague as far as there is no minimum percentage requirement that triggers code compliance. If you're doing a roof replacement on a section of roof that has isolating parapet walls, then full code compliance in that isolated area would be triggered. If you're doing repair on the portion of a larger roof What we tend to say is that if you've got water damage at one spot, it's probably spread to a larger area, in which case you're pulling off the membrane from the roof, and fixing insulation in more areas than just that one damaged spot, most likely. So if you've got a leak or damage in one area, you probably ought to be doing a full roof replacement.
Question regarding change of occupancy. Is it both increasing and decreasing? The code calls out this is only if you are increasing the demand for fossil fuel or electricity. So if you go from an energy intensive use to a less energy intensive use, that does not trigger the 505 change in occupancy. Only if you are increasing the energy use for that.
Okay, we got a question here about if IECC has done any life cycle energy analysis to see if the embodied energy required to force upgrades due to a change of occupancy might outweigh the operating energy savings. What we do point out here is that the life cycle analysis studies done on the codes are for new construction, generally. However, for an existing building, you would expect that once the upgrades are done to that building, that you're going to expect a similar typical building life of 50 plus years out of that structure. And so, similar to new construction, the cost benefits of the additional insulation, reducing the size of the HVAC equipment and making that more efficient does balance out.
As far as, let's see here, any resources regarding the completion of ComCheck and ResCheck, the Energy Codes website does have some resources. I believe we have also done a couple of webinars in the past that may be of assistance to you for completing those as well. So I would check our website along with the ComCheck and ResCheck websites for some additional resources for that.
We've got a couple of questions here regarding change of use in a portion of a building. So we got one about a warehouse where you're just changing the upper floors to residential. We've got one about, we gave an example earlier of a warehouse that was adding conditioned offices within an unconditioned warehouse. So that portions of a building can change use. Those portions would have to fully comply with the code. The unaltered portions of the building do not need to comply. They can remain as is.
Depending on how that is, you might go ahead and alter the unaltered portions just to make it easy. Because as is alluded to in the question regarding, we're going to convert upper floors from warehouse to residential, and the bottom floor is going to remain warehouse, presumably. You might find that in order to do compliance, it's easier to go ahead and cover the whole building rather than just the resident, than trying to just get the residential to comply. Industrial buildings. They are, for the purposes of energy code, considered commercial. The definition of a commercial building for the energy code is anything that is not a residential building. So industrial buildings, they do have some things such as equipment buildings that are commonly associated with cellular towers and radio towers. But yes, so industrial buildings follow the commercial provisions. Excellent. Someone picked up on controlled receptacles. The energy code does not at this point in time call that controlled receptacles needs to be added as part of an existing building, unless perhaps you trip over 505, in which case all of chapter 4 applies. But yeah, unless you trip over 505, alterations do not at this time require the addition of controlled receptacles where none exist. You could not necessarily take out controlled receptacles, as that may reduce the compliance, but the code does not say you need to necessarily add them where they don't already exist.
Yeah, that's acknowledging that to add controlled receptacles in a portion of a building may require destructive work in other portions of the building that would otherwise have been unaltered to access wiring and circuits and stuff. So that is currently not in the existing buildings provisions. Question about how can a blower door test be successful in a warehouse with dozens and dozens of dock levelers, all of which have gaps to the exterior required to properly function? So we get questions around dock levelers for thermal envelope as far as the installation of the insulation, as far as alignment with where is the thermal boundary around that dock leveler. Ideally, those levelers would be outside the thermal envelope and your air barrier and insulation would be inside so that those air gaps aren't within the thermal envelope. But we do acknowledge that that's not always the easiest way to build buildings where you have all these insets around the dock levelers. So
that will make you, you'll need to either find a better way to air seal those, or it's going to mean that the rest of your envelope is going to have to be that much better to accommodate and account for the poor air sealing around the dock levelers.
The nice benefit for warehousing is that air leakage is envelope area based and not volume based, which can give you a little bit more leeway.
Clarification on the lighting, moving some lights around. So this is for an interior remodel. The wall layout is changing, requiring the relocation of multiple fixtures. Are those counted towards the 10% rule? Given we are dealing with wall layout changes, you are likely in an alteration at this point. That's not just a that's not just a fairly simple. I need to move a fixture. So yeah, when you're dealing with wall layout changes, oftentimes you're dealing with potential life safety code issues, egress issues. So that's a much bigger project than I just need to change a light. Again, fortunately, because of where the lighting requirements are, meeting those thresholds are not terribly difficult for that, given current lighting technology out there.
That also falls into kind of the change of use. There is a specific note for lighting where if you're changing a individual space from one lighting usage category in either the building use or space by space category to another, that does trigger compliance for that space. So if you're creating new rooms, then those would have to meet the lighting power density requirements for that usage type. A good call out here too for in the chat regarding public schools. Public schools are have a different authority having jurisdiction than the rest of the state. So the State Board of Education and the Superintendent for Schools does approve their own code cycle. They are currently on the 2015 IECC. So public schools are on the 2015 IECC. We have heard that they are expected to update that for the next code cycle, but that is correct. Public schools are on the 2015 IECC, not the 2021.
With that, I want to thank everyone for joining us today. I think we got the questions, but if we missed yours, again, feel free to reach out to us, energycode@illinois.edu. On behalf of myself and Sean, I want to thank you all for joining us today and have a great afternoon.